So our topic is derivative of inverse trigonometric function. In short, this is ITF. The formulas are respectively ddx of, all the formulae. Ddx of sine inverse x is equal to 1 upon root over 1 minus x square. This is the first formula. Next formula is ddx of cos inverse x is equal to minus 1 upon root over 1 minus x square. Next, ddx of tan inverse x is equal to 1 upon 1 plus x square. Next, ddx of cot inverse x is equal to minus 1 upon 1 plus x square. Next is ddx of sec inverse of x is equal to 1 upon modulus x root over x square minus 1. And finally, ddx of cosec inverse x is equal to minus 1 upon modulus of x root over x square minus 1. Okay, this formula actually these are discussed earlier in the previous tutorial, so you have to see all the tutorials which are prepared earlier. Now you have to know the respective trigonometric inverse functions and their domain and ranges. Okay, first one is sine inverse, next is cos inverse and tan inverse. Okay, their corresponding domain and their ranges. Okay, range. So sine inverse is domain is from minus 1 to 1, closed interval minus 1 to 1, range is closed interval minus pi upon 2 comma pi upon 2. Next, cos inverse, its domain same, minus 1 to 1 oscillatory function, and its range is 0 to pi, closed interval 0 comma pi. And tan inverse its domain is r and range is minus open interval minus pi upon 2 comma pi upon 2. Okay, so now we shall see few more important trigonometric substitutions and their corresponding formulae to utilize them in the derivative of inverse trigonometric functions. Okay, first formula, sin 2x. What is the formula of sin 2x? You know this one, sin 2x is equal to 2 sin x into cos x. These will be substituted in the proper places. Okay, 1 plus cos 2x. What is 1 plus cos 2x? This is equal to 2 cos square x. Next, cos of twice x, that is equal to 2 cos square x, 2 cos square x minus 1. It may be utilized in proper place, cos 2x. From this one, cos 2x is equal to 2 cos square x minus 1. And next is 1 minus cos 2x is equal to 2 sin square x. Okay, 2 sin square x, or from this one you can write cos of twice x is equal to 1 minus cos of twice x. Cos of twice x is equal to 1 minus 2 sin square x. Okay, next you can write tan 2x. Okay, what is tan of twice x? Tan 2x is equal to 2 tan x divided by 1 minus tan square x. You can write sin twice x. Sin twice x is equal to 2 tan x divided by 1 plus tan square x. Next, cos twice x is equal to 1 minus tan square x divided by 1 plus tan square x. Okay, now few more inverse functions and their corresponding formulae. Sin inverse of x into root over of 1 minus y square plus y into root over of 1 minus x square. What is the formula? This formula may be of several patterns. First pattern may be sin inverse x plus sin inverse y. If you should know this one, minus 1 less than or equal to x comma y less than 1. Okay, this is very important. And not only that, and x square plus y square is less than or equal to 1 if xy is less than 0 and x square plus y square is greater than 1. Next, maybe this is one pattern. Next pattern may be you can write pi minus sin inverse x plus sin inverse y. This is another pattern. So you can apply it only when if 0 less than x comma y less than 1 and obviously x square plus y square is greater than 1. This is another pattern. Okay. So in the next page you may see few more inverse trigonometric functions and the formulae. First formula, this is very important formula, tan inverse of x plus y upon 1 minus xy. So what will you write? You can imagine it will be tan inverse x plus tan inverse y. Yes, it is obviously correct, but it is only when xy is less than 1. There is another formula, you may write this one also, pi minus tan inverse of x plus tan inverse of y. This is only when x is greater than 0, y is greater than 0 and xy is greater than 1. Mind it, this is very important. Another formula may be written, it is pi plus tan inverse x plus tan inverse of y. Okay, tan inverse y. This is only when x is less than 0, y is less than 0 and xy is greater than 1. So few more important questions. Formulae. The formula is of sin inverse x plus of cos inverse x. You know this formula and you will definitely write it as pi upon 2. And this is only when minus 1 less than or equal to x less than or equal to 1. Another formula, this is tan inverse of x plus cot inverse of x. So this is equal to pi upon 2. All the directions are given in ITF for all x belongs to R. And last one I want to write, it is a sec inverse of x plus cosec inverse of x. This is also pi upon 2 if x belongs to the open interval, semi-closed interval minus infinity to minus 1 union 1 to infinity. Okay. So these are the few important trigonometric formulae. So you will apply it in the derivative of the inverse trigonometric functions. So first problem we want to take in the next page. You have to write all the formulae. Please carefully write. If you commit any mistake, then these will not be utilized in proper place of the derivative of inverse trigonometric functions. So for first question is this one. You have to find out the derivative, differentiate cos inverse of 1 minus 2x square with respect to x if the domains are given. This is very difficult if the domains are given. If no domain is given, that means you have to consider in general case. Okay, the first domain is given 0 less than x less than 1 and the second domain is given minus 1 less than x less than 0. So one by one. The function is cos inverse of 1 minus 2x square. Let us consider that y is equal to, this is the solution. Okay, y is equal to cos inverse of 1 minus 2x square. Okay, now what will be the substitution? This is very important. You have to understand the substitution. Putting x is equal to sin theta. Without this one you can't evaluate this inverse trigonometric function, because 1 minus 2 sin square theta, there is a formula. 1 minus 2 sin square theta is equal to cos 2 theta. Earlier I write this one. So you have to write this one, cos inverse of 1 minus 2 sin square theta, isn't it? So this is obviously cos inverse of cos 2 theta. So according to the formula, cos inverse of cos 2 theta. So what will you write? You will write only 2 theta, isn't it? But why do you write 2 theta? Before that you have to study the domain. What is your domain? This is the first case. The domain is 0 less than x less than 1. That means 0 less than, what is x? X is substituted by sin theta. So this is sin theta less than 1, or this will be 0 less than theta less than pi upon 2, isn't it? 0 less than sin theta less than 1, that means sin pi by 2 is equal to 1 and sin 0 is equal to 0. So for this 0 less than theta less than pi by 2, what is the angle? This is 2 theta. For this you have to multiply all the pattern by 2, so that 0 less than 2 theta less than only pi, because pi upon 2 into 2 means only pi. So 0 less than 2 theta less than pi, and 0 to pi, you see what is our range of cos inverse. You know, the I have written earlier cos inverse and its domain. What is domain? Domain is from -1 to +1. This is very important. If you don't understand, then all will be in vain. And the range is the closed interval 0 comma pi, isn't it? So you find that this is 0 to pi, this is closed interval 0 to pi. So obviously this angle is in the range value, so you can apply directly here. So the y, this y will be cos inverse of cos of 2 theta, and immediately, since the angle lies in between the range, so you can write it is as twice theta. So y is equal to twice theta. What is theta? Theta is equal to, obviously from here you have to find theta. Theta is equal to sin inverse of x, isn't it? So sin inverse of x, substitution. So y is equal to sin inverse x, so dy dx is equal to 2 into ddx of sin inverse x, isn't it? Sin inverse x. So ddx of sin inverse x means 1 upon root over of 1 minus x square. 1 upon root over 1 minus x square. This is not showing here. I write again this one. 2 upon root over of 1 minus x square. Okay, this is the result for only for the domain 0 less than x less than 1. Second domain is not written. Now I am writing this second domain. For the second case, your domain is -1 less than x less than 0. That means -1 less than x. What is x? X is equal to sin theta. So write sin theta less than 0, isn't it? So -1. So this is what will be this one? This is minus pi upon 2, isn't it? Minus pi upon 2, because sin of minus pi by 2 is equal to -1. So this is theta and less than 0. Minus pi upon 2 less than theta less than 0. What is your angle? Angle is twice theta. This is your angle, twice theta. So you have to, now what to do? You have to multiply by 2, so that you are getting minus pi less than 2 theta less than 0. Now is it your domain minus pi to 0? Is it your domain, sorry, range? No, your range is 0 to pi. So you have to make it 0 to pi or a part of 0 to pi. Okay, so you can do this one, very simple. This is 0 less than minus 2 theta less than pi. So simple. So now you see that the range is as in the format given, the closed interval 0 to pi. So now you may put the substitution carefully. So y, what is y? Y is cos inverse of cos 2 theta, isn't it? Y is cos inverse of, y is equal to cos inverse of cos 2 theta, but you can't write now 2 theta. It will be cos inverse of cos of minus 2 theta. Okay, cos inverse of cos of minus 2 theta. So y is equal to minus 2 theta. That means y is equal to minus 2 theta. Theta is equal to, what is theta? Theta is equal to sin inverse of x. This is sin inverse x. Therefore dy dx, what is dy dx? Dy dx is equal to minus 2, as usual, derivative of sin inverse x is equal to 1 upon root over 1 minus x square. So this is minus 2 divided by root over of 1 minus x square, hence the result. So if the domains are given, respective domains are given, then the problem becomes quite extent difficult for you. So you have to study the domain, then the range, and you have to find out the angle, the supplied angle should be kept in the corresponding range, so that you can substitute properly. Okay, this is very important. You have to write the answer in your copy and carefully understand and practice at your home. Next question. Okay, differential again. Carefully watch this question also. This is also one interesting question. Differentiate tan inverse of twice x divided by 1 minus x square with respect to x if the domains are given. First domain, okay, carefully watch. First domain, what is the domain? X belongs to the open interval minus 1 comma 1. Second domain, x belongs to the open interval minus infinity to minus 1. Third domain is x belongs to 1 comma infinity. Okay, now you have to remind again the range and domain of tan inverse, because your function is now tan inverse of this one, na? So tan inverse, okay, I write tan inverse, its domain and range. Okay, what is the domain? Domain of this one is R, and range is open interval minus pi upon 2 comma pi upon 2. Okay, so range and domain are known. Now we have to differentiate. First, we take for the function given as usual. So let y is equal to tan inverse of twice x divided by 1 minus x square, and you quite extent sure that you will substitute it as x as what to do? X is equal to tan theta. Obviously, you know 2 tan theta divided by 1 minus tan square theta is equal to tan 2 theta. So this is the proper substitution. Now, can you write tan inverse of tan 2 theta is equal to 2 theta or anything else? So we have to study. So first of all, you write this is tan inverse of 2 tan theta divided by 1 minus tan square theta. Okay, so this is equal to tan inverse of tan 2 theta. As usual format we have written, but we did not study the domain given. So first domain we are studying, the first domain. Okay, what is given? Minus 1 less than x less than 1. This is given. X belongs to the open interval minus 1 comma 1. That means minus 1 less than x less than 1. This is given in your question. So obviously minus 1 less than x. What is x? X is equal to tan theta. Therefore theta is equal to tan inverse x. Theta is equal to tan inverse x. So substitute this one. Tan inverse of this is x is equal to tan theta. So theta is equal to tan inverse x. Now x is replaced. This x is replaced by tan theta. This will be tan theta. 1 minute please. I have to wrap this one. This will be tan theta. Okay, this is tan theta is less than 1. Now minus 1 means minus pi by 4 less than theta less than pi by 4. You know this one, tan pi by 4 is equal to 1, tan of minus pi by 4 is equal to minus 1. So minus pi by 4 less than theta less than pi by 4. But what is the angle? Angle is twice theta. For this you have to multiply by 2, so that you will get minus pi upon 2 less than twice theta less than pi upon 2. Now your angle is 2 theta as the format of 2 theta, and you have to adjust with the range. Minus pi by 2 to pi by 2, is it the range? Obviously the range is adjusted here. So you will just write 2 theta. Don't change this to theta. So you have y. So y is equal to, so you can write y is equal to tan inverse of tan 2 theta as usual format, no change. So this is twice theta. What is theta? Theta is equal to tan inverse of x. This one, theta is equal to tan inverse of x. So y is this one. Therefore dy dx. dy dx is equal to 2 times ddx of which one? Tan inverse x. So this is 2 divided by 1 plus x square. Hence the result. This is the result for the first case, first domain. Okay, first domain, x belongs to minus 1 to 1. Next domain is minus infinity to minus 1. So I change the color. This is number 2. Okay, number 2. What is given? Minus infinity less than x less than minus 1. This is given in your question. X belongs to open interval minus infinity comma minus 1. So this is 1 obviously. Minus infinity less than x. What is x? X is equal to tan theta. X is equal to tan theta. So substitute tan theta less than minus 1, isn't it? So minus infinity, that means what to substitute here? Minus infinity. So it will be obviously minus pi upon 2, because you know minus 10 of minus pi by 2 is equal to minus infinity. So this is angle is theta less than minus 1. Minus 1 means 10 inverse of minus 1. So tan inverse of minus 1 obviously minus pi by 4, minus pi by 4. Okay, this is minus pi by 4. So minus pi by 2 less than theta less than minus pi by 4. So you can write now it as minus pi less than twice theta, because the angle is twice theta. Okay, since the angle is twice theta, you have to make this theta as twice theta. So multiplying all the pattern by 2, so that minus pi less than twice theta less than minus pi upon 2. Is it your range? Is it your range? No, no way. This is the open interval minus pi upon 2 to pi upon 2. Now you have only minus pi less than 2 theta to minus pi upon 2. So you have to adjust the angle, because you have to attain this range or a part of this range. So better you do this one. You can write it as 0 less than pi plus 2 theta less than pi plus pi minus pi by 2, that is only pi by 2. Do you understand this one? Just add pi to all the terms of this pattern, that is pi minus pi is equal to 0, pi plus 2 theta is written, and pi minus pi by 2, that is equal to pi by 2. Okay, now you see this is 0 to pi. The range is now 0 to pi. Is it this one? That means this is the part of this given range. So this is okay. So your angle is now pi plus 2 theta. Pi plus 2 theta. So this 2 theta will be interchanged by pi plus 2 theta. So you have to write now y as y as tan inverse of tan 2 theta. What is theta? 2 theta. Now this 2 theta will be replaced by pi plus 2 theta. Okay, so pi plus 2 theta. Carefully understand, otherwise all will be in vain. Pi plus 2 theta. Okay, so this is pi plus 2 theta. What is theta? Theta is equal to tan inverse of x. From where do we get this one? This is theta. Theta is equal to tan inverse x. So I have written. So y is equal to this one. Now you differentiate. Okay, you have to differentiate. Dy dx is equal to ddx of pi plus 2 tan inverse x. So this is 0, derivative of pi is 0 plus 2 divided by 1 plus x square, hence the result. This is the result for the second part. Okay, this is the result for the second part. 2 divided by 1 plus x square. Dy dx is equal to 0 plus 2 upon 1 plus x square. This is the result for the second part. Now I have to do the third part also. Now what is the third part? Third part is x belongs to x belongs to 1 to infinity. So there is not sufficient space, so I have to go to the next page. Okay, have you written this one? So I have to go to the next page. Okay, so first of all you remind that y is equal to tan inverse of tan 2 theta. I have to use this one. So go to the next page. Okay, now what is your domain? Domain is given as x belongs to the open interval 1 comma infinity. That means 1 less than x less than infinity. Okay, so 1 less than x. What is x? X is equal to tan theta. X is equal to tan theta. You see the previous page. X is equal to tan theta, isn't it? X is equal to tan theta. So theta is equal to tan inverse of x. Okay, so go to next page. So this is less than theta infinity. So you can find it here, pi upon 4 less than theta less than tan inverse of infinity. What is this? Tan inverse of infinity means pi upon 2, isn't it? Pi upon 2. Now your angle is 2 theta, not theta, so make it 2 theta. Where do I get 2 theta? See, in previous page this angle is 2 theta, this one 2 theta. So go to next page, again I write, so it will be multiplied by 2. So on this one, this is pi upon 2 less than twice theta less than pi. Pi upon 2 less than 2 theta less than pi. Is it your range or the subset of range? So see the previous page, the range is minus pi upon 2 to pi upon 2. No, so for this you have to adjust this one, you have to make this range or a part of this range. So what to do? Obviously you have to do this one, pi upon 2 minus pi less than 2 theta minus pi less than pi minus pi. I have subtracted pi from each the term, so that this is minus pi upon 2 less than 2 theta minus pi less than 0. This is a part of your range. See, again see, that will be better. So open into minus pi by 2 to pi by 2. So this is the part, this is the part, minus pi by 2 to 0, this is obviously a part. So you have to substitute your angle 2 theta by 2 theta minus pi, isn't it? So simple. So what was, okay, see, again see, what is the function given? Y is equal to tan inverse of tan 2 theta. This 2 theta will be replaced. So right, y is equal to tan inverse of 10. Now what to write? This is 2 theta minus pi, 2 theta minus pi. So write 2 theta minus pi. Okay. So this is equal to tan inverse of minus 10 of pi minus 2 theta. Okay. So this is equal to tan inverse of 10 of no need to write this line, you have to rub this one. Okay, no need to write this one. This is the same step will be repeated. Tan inverse of 10 of 2 theta minus pi. So this is obviously 2 theta minus pi, or y is equal to 2 theta. What is theta? Theta is equal to, obviously in the previous page it is written theta is equal to tan inverse of x. Okay, so theta is equal to tan inverse of x minus pi. Now you have to differentiate on both sides with respect to x, ddx of 2 tan inverse x minus pi. Okay, so 2 into derivative of tan inverse x is 1 upon 1 plus x square minus derivative of pi is a constant, so 0. So ultimately what are you getting? 2 divided by 1 plus x square, 2 divided by 1 plus x square. This is your result. Okay, so I have discussed 6 formulae of derivative and the trigonometric formulae also, which are studied in class 11th standard. And after that I have studied a few more important questions, and these questions are important for this. The domains are different as you think about the questions. So for these questions are very important. Studying the domain, you have to find out the range of the corresponding angles, so that you can do these problems in a proper way. So in the next session you will find the logarithmic function and many more functions and their corresponding derivatives. So till then, bye bye, take care of you.